Good afternoon, my YouTube viewers. It is Crystal here, and I've just got another code review to do for you, and the title of this program is going to be Numb Employees, ARIMA versus Holt Winters. And I know that I have done ARIMA versus Holt Winters code reviews in the past, but I've been trying to perfect my technique because when we were doing ARIMA, the for loop that I had been given for ARIMA didn't seem to be working very well. So I've got another for loop, and this new for loop works a lot better. And since it works a lot better, I wanted to go ahead and do another code review with this new for loop that works a lot better so you can see how it works for yourself. So this is basically a data set that I put together myself where I was compiling training deficiencies over a period of years, and I was able to find out how many employees were in this organization and what they were lacking in training. And so that's what we've done. And so what I've done is I dropped the lacking in training column, and I just made a number of employees column. So the only thing that you're going to see in this column is number of employees. I created the program in Google Colab, which is a free online Jupyter notebook hosted by Google. It's a great platform to use. I like it a lot, but the only disadvantage that I see of it is it doesn't have a very good undo function. And since it doesn't have a very good undo function, if you accidentally delete or overwrite code, you're going to be in big trouble. But one thing that you can do is you can click on, which I'm not going to do it, but you can click onto the saved history, and you may be able to retrieve old code if you click onto the saved history, which I've had to do a few times in the past when I've accidentally deleted or overwritten code. So what we'll do is, now that I've told you a little bit about this data set and how I created it, I'm going to go over and go through the code. The first thing we're going to do is we're going to import our libraries. So we're going to import pandas as PD, and pandas is a data processing library that creates and manipulates data frames. Then we're going to import NumPy as NP, and that's a numerical library that carries out numerical computations and creates NumPy arrays. And then we're going to import math, which is an inbuilt library in Python, and it performs mathematical computations such as square root, which you'll need. We're going to import stats models as SM, and really it should be statsmodels.api. Should be statsmodels.api as SM. And what that does is that statsmodels is a statistical library that does linear regression, logistic regression, statistics, and time series analysis and forecasting. So we're going to import a matplotlib, pyplot, SPLT, and what that is that's a graphics library. And we're going to import Seaborn as SNS, and that's a higher level graphics library. And what it does is it also plots the data in a statistical format, whereas matplotlib doesn't. And then we're going to import warnings. So like when we're going through this for loop, it's going to ignore the warnings so you don't get warnings whenever you run through the for loop. So after we've imported our libraries, we're going to load the file. We're going to use pandas to load the CSV file. And this is my personal file, but you can get it, you can find it on Kaggle if you want to load it. I'll see if I can find it for you. You go into datasets, and I'm going to go into my work, and then so analyze training deficiencies. I did that 12 days ago, but let's just look at it and see what it says. So I had one download. So if you are interested and you actually want to follow along with me on this program and you want to use the data set that I used, well, you've got it on Kaggle. I've uploaded it onto Kaggle, so it's there on Kaggle for you to use. And then on this particular data set, it has two columns. One is number of employees and two is training deficiencies. And I was trying to find something that had as little trend and seasonality as possible. So that's why I chose number of employees, because I was looking for something that no trend, no seasonality, nothing that the program could get hung up on. So now what we're going to do is we're going to drop training deficiencies, and so now the only thing you have is the two columns, the month and the number of employees. We do an info when we find out the month is an object and the number of employee is an integer. So what we have to do is we have to configure the dates. And the reason why, because I did this CSV file in Excel, and the month and year in Excel is not compatible with the month and year in Python. So I had to make it compatible. So I had to use string operations. So for the month, I took the first 3 characters of the string, and then for the year, I went to the 4th character and took the 4th character to the end. And then I created a column called month year, and then I took the month plus 20 plus the year, so it would put 20 in front of the year. And then after that, I dropped the month. And then whenever I got my month year, I used pandas to timestamp it. So now it's a time stamped. And then not only did I do that, the DF index was time stamped with series month year, and then series index equals series month year. And then what we did was we dropped month year and month year, so we didn't need that anymore. So we just dropped all of the columns that we didn't need anymore. So now you've got the index, which is month year, and then you've got the number of employees, and that's all you've got. So that's what I did, and that's the methodology that I used to do it. Now we check for null values again. There's no null values. And now we plot the series. We plot the series onto a graph, and you can see that it does have some seasonality. It does have some seasonality. And I will say that I kept track of this training during COVID. And so that's one of the reasons possibly why you had a dip from 119 employees. So you got anywhere from 119 employees to 134 employees. And then we did a hist plot, so you can see the hist plot. So now what I did was I did a 2-side view of the number of employees, and I got tired of looking at sea green, so I made it pink. I made the 2-side view pink, so you can see the number of employees there. So now what I wanted to do is I set up some box plots. So we had series month equals series.index.month, and you can see the box plot. You had the most employees on February, and you had a dip in the employees in June. So that's very interesting. And then we had checked out the day of the week. And so series day of the week equals series.index.day of the week. And then so you had like on the 5th day of the week, the first day of the week is a Monday. And so the 5th day of the week is a Saturday. So you had like the most employees, it looks like, the most employees on a Saturday and a Friday. And those are just some little box plots and things that you can do. And this is interesting. It talks about the week of the year equals series week of the year equals series.index.week of year. And so you can check to see what's happening each week of the year. So we had a few box plots and then a few just lines because I only kept the data for something like 3 years or something like that. So it wasn't a long time to keep the data. If I had kept the data for longer, I'm sure I would have had better box plots. Now what we're going to do is now that we've done our box plots, we're going to drop unnecessary columns. So we're going to drop month, day of week, week of year, and we go back to just this data frame with just the index and the one column. So now we check statistics. So your max value is 134, and that was month, and that was row number 1. And then your min value is row number 17, and it was 119. So that's what I said before. You had anywhere from 119 to 134 members of staff. Now we're doing some smoothing just to see what the figure would look like if it's smoothed out. And now we're going to split the data frame up into training and testing sets. So the training set is going to be 90% and the testing set is going to be 10%. And now I'm doing the Holt Winters method. And the reason why I did the Holt Winters method is because it is one of the easiest models to use because it incorporates seasonality and trending within the model. So you don't have to do anything to your data set to use Holt Winters method. It's ideal for those data sets that have seasonality and trend. And then we check our model. After we've done the model equals exponential smoothing, train number of employees, seasonal periods equals 12, trends equals add, seasonal equals add, frequency equals MS, and MS means month start, and then we fitted it. We printed a model.AIC, and AIC is a value that lets you know how well the model is. So you want the numeric value to be as low as possible. So 88 is pretty good low value. Now what we do is we predict on our model, and we predict on y hat, and then so we have four rows of data for our prediction, and that's your prediction. And then we check for our error. Our error is RMSC is 3.67, so that's pretty good. So, and then what we do is we do predicted. So I think hopefully I don't crash it, but let's just see. What I would do here is I would say to make them all integers, I'm going to run it. I'm going to bite the bullet and run it. It's taking just a little while for it to do it. It has to mount it on the drive. It says cannot convert series to int. About round. Try that. Maybe it'll let you round it. Okay, so it rounded it. So we'll run it again. So we rounded our figures. Because you can't have like a fraction of an employee. But we rounded it to 0. So okay, so now that looks better. So we plotted it. So now you can see the plot with Holt Winters. You can see the train at the training section, and then you can see the amber is the test section, and the green is the Holt Winters forecast. So you can actually see the whole forecast there. So now what we're going to do is we're going to check for stationarity. And the stationarity was 0.35, which I was like really amazed that it had stationarity. And the reason why that is because yeah, it was such a small data set. But one thing that, let me just go through and check something. So we're going to check a series stationarity plot. So that's it, our series stationary. And you can see it looks a lot different from the regular data set. So if we put it in an if-else statement, so if it's greater than if the p-value is greater than 0.05, then it's not stationary. And so what we do is we use differencing to try to make it stationary. So that was good. I was really surprised that it wasn't stationary because it was such a small data set. It had such small values. And then so we use differencing. And so adjusted result by differencing is 0.002. So that's less than 0.05. So we made it stationary. And then so the ADF statistics is negative 3.8, and then your p-value is what you want to see is 0.002 after we've done our differencing. So you can see there's the stationary plot. And this is just reversed by differencing. So that's just to reverse it. So now you've got number of employees, stationaries, and reverse difference. And you can see the reverse difference is the same as the number of employees. So we check the series number of employees. So you can see that's what we started out with. And we do reverse differencing. It's the same as the series number of employees. So now what we're going to do is we're going to split our data frame again. I had to do that in order to get the ARIMA to work. And then we're going to check for mean and variance, because mean and variance is another thing that you can check to see if it's stationary. So if you have a discrepancy between the mean and the variance, if you have a discrepancy between the mean for the train set and the test set, and then a discrepancy in the variance for the train set and the test set, then that means the data set isn't stationary. So I was really surprised that the data set wasn't stationary because it had such small values. It had from 119 to 134. So again, that's another reason why you need to check for stationarity, because even if you think that a data set is stationary, I mean, you need to check mathematically to see if it's stationary. So again, it says that for train set, the mean was 127.259. For test set, the mean was 130. The difference was negative 2.74. And then for the variance, the difference was 12.199 between train and test. So now we're going to analyze the test. We're going to do a disk plot on the number of employees now that we've used differencing, and you can see that there's a big difference there. And now what we do is we do seasonal decompose. And what this seasonal decompose does is it decomposes the time series. So you can see the observed time series, and then you can see the trend. You can see that there is a trend. There's a dip in the middle of it, and then you check for seasonality, and you can see that there is seasonality, and the residual is just like noise. So I was really surprised that such a small data set had so much going for it. Now we're going to check our ARIMA. So we're going to check our PDQ values. P and Q are 0 to 7, and D is 0 to 2. I think it's really going to be 0 to 3. Okay, and now what we're going to do, I hope it works because I worked so hard to get it to work. We're going to put it on the it says from statsmodels.tsa ARIMA.model import ARIMA. And it says no module name stats models TSA ARIMA. Well, let's just check this out. Let's just try this. It's always something. I worked so hard on it to get it to work, and then I call it up again. Let's try it. No. No. What I'm going to do in order to get it to work, and you can see how hard it is because I was working on it this morning. And some other models this morning, and it wasn't working. But we're going to try our best. And what we can do is we can do this. We can say so it says right here, stats models, TSA, ARIMA, model, ARIMA. So it says stats models, TSA, ARIMA, model, ARIMA. Let's try this. Try it again. So you can see it's always something, you know. I thought that I had it working, and it is. Time series, stats models is very difficult to work with. Let's try this. It says right here, you can see I lose a lot of sleep as well working on this. see what it says. It says SM TSA ARIMA .model. SM TSA dot. Try it again. So it's not working, so we'll try to get it to work. So the order works. So it's the model that's not working. Try it once more. Nope. So it's this that isn't working. It's this line of code that isn't working, and it was working before and now it's not working. So it's something to do with this model, and as you can see, it's hard. I mean, it's very hard to find the code to use. See, that says, here you go. Oh, it's doing something. So I'll take out the print model. It's doing something. So that's good. So now, and it's a bit difficult for me to do all this, online, because I have to correct the mistakes, because that's one of the problems we have is we work on it and we think, oh, I've got it working, and then something happens and it's not working anymore. So now what we have to do is we just have to wait for it to iterate through the code, and here's the code right here if you want to look at the code and copy it. So what we're doing now is we're just waiting for it to iterate through the code. Oh, so it's finished iterating, thankfully, and it said 210 is your lowest RMSE. So we're going to check here. We've got a AIC of 135, and so now what we're going to do is we're going to make our prediction and plot it on the graph, and you can see that we've got the amber is our actual values and the ARIMA forecast is the green. And so you can see that the ARIMA forecast is very similar to the actual values. And then we do test in y-hat. Check our error, and so you've got RMSE of 1.4, and then you can compare your actual values against the predicted values. So for the ARIMA, we have an RMSE of 1.4, and let's see what we've got for Holt Winters. With Holt Winters, you have an RMSE of 3.96. So in this particular instance, ARIMA outperformed the Holt Winters. So I hope you can see just what I go through. You know, I get the code to work, and I'm really pleased because I've got the code to work, and then I go turn it on and run it through again, and it doesn't work. So it's really hard. So you can see on YouTube just what I have to go through. But this completes our code review, and I had to troubleshoot some problems in the middle of the code review, so you could see that as well. So I'm going to go ahead and conclude this video because we compared the ARIMA model to the Holt Winters model, and you can see that in this particular instance, the ARIMA model outperformed the Holt Winters model. And I would like to thank all of my subscribers for subscribing to my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video. And I look forward to making more videos for you in the future.